So students, myself is Dr. Kapilori, working as lecturer in civil engineering department and major Polytechnic College, University. So now, sir, now students in this PowerPoint presentation, I am giving on the volume relationship, volume mass relationship or mass volume relationship, mass volume weight or weight volume relationship. So students, some definitions and relationships based upon volume. There are void ratio with symbol E, porosity with symbol N, degree of saturation with symbol S, air content with symbol AC, percentage air voids with symbol Na. So student, these symbols you have to remember. These are most important symbols because further every calculation has to be represented by symbol. So void ratio you have already studied. That is equal to volume of voids to the volume of solids. Now, student, what is porosity? Porosity is defined as the ratio of volume of voids to the total volume. It is denoted by N. So this is the formula of porosity. N is equal to volume of voids to the total volume. It is generally expressed as percentage. Porosity of a soil cannot be exceed 100% as it would mean volume of voids are greater than volume total volume, and which is not possible. In fact, it has a much smaller value. It is also known as percentage voids. Both porosity and void ratio are a measure of voids, that is looseness or denseness of the soil. However, term void ratio is more commonly used in soil mechanics. So, an interrelationship between porosity and void ratio can be derived as under that, as we know, N is equal to volume of voids. Therefore, 1 over N is equal to volume of voids to the total volume. So, this becomes reciprocal. So, this is total volume of voids is equal to volume of voids plus volume of solid, as I had already told you. So by substituting these values, we can get the value of porosity in terms of void ratio. Similarly, we get void ratio in terms of porosity. Degree of saturation, that is S. It is the ratio of volume of water to the volume of voids. So volume of water to the total to the volume of voids. So degree of saturation indicates the volume of voids which has been occupied by water. For fully saturated soil, volume of voids, volume of water is equal to volume of voids. So when we have three types of soil, that is fully saturated soil, dry soil, and partially saturated soil. For fully saturated soil, we have take the value of S is equal to 1. For dry soil, we have to take the value of S is equal to 0, and for partially saturated soil we have to calculate the value of S by this formula. Now air content, it is denoted by AC. It is the ratio of volume air voids to the volume of voids as expressed as percentage. So this is the formula of air content. So air content is 0 when the soil is fully saturated. As you know that the value air content we have to calculate when the soil is dry or partially saturated. So this is the percentage of air voids that is denoted by NC. So this is the formula, and for calculating the percentage of air voids, we have to multiply and divide this formula by volume of voids. So see, so this is the formula, and this is the end result of percentage of air voids. Now water content. Water content is denoted by W, also known as moisture content. it is equal to the ratio of mass of water to the mass of solids. So see what is the symbol of this mass of water and mass of water and mass of solids. So this is the formula. So students, one I had already told you the weight can be replaced by uh, mass m, the value of mass can be replaced by weight. So here you can also write in place of m, in place of m you can write w. Here you can also write w. So you can also write this in case of weight. When, okay students, so it is expressed as percentage. Fine-grained soils have higher value of water content as compared to coarse-grained soils. In general, the value of water content is greater than or equal to 0. There is no upper limit for water as such, therefore W can be more than 100%. Therefore, mass of water can be more than mass of solids. So these are the volume mass relationships. So mass density is equal to mass over volume. So bulk density, dry mass density, saturated mass density, submerged mass density, mass density of solid. So I again repeat: bulk mass density, dry mass density, saturated mass density, submerged mass density, and mass density of solids. So these are the definitions of bulk mass density, dry mass density, saturated mass density, submerged mass density. So students, you can see from the so you can see from this bulk mass density is denoted by rho, dry mass density is denoted by rho d, saturated mass density is denoted by rho saturated, and sub mass density is denoted by rho dash, and mass density of solids is denoted by rho s. So students, now, what is the definition of mass, mass density or bulk mass density? It is denoted by total mass per unit total volume. So, students, total mass and total volume you have to calculate in the same way as I had explained you earlier. That is, total mass is equal to mass of water plus mass of solids. And total volume is equal to volume of air plus volume of water plus volume of solids. Or you can also write total volume is equal to volume of voids plus volume of solids. So this is the formula of bulk mass density. It is also known as bulk density, wet density, or simply density. It is expressed in kilogram per cubic meter or gram per milliliter or gram per cubic centimeter. Or dry mass density, it is denoted as mass of solids. This you can only get what is dry mass from the dry mass density. It comes only mass of solids to the per unit total volume of the sample. This works. So the solids may shrink during drying. Therefore, the total volume is measured before the students. So total volume is to be measured before drying, as because solids may shrink during drying. Now, saturated mass density. It is the what is saturated mass density? It is the bulk mass density of the soil when the soil is fully saturated. So saturated mass density क्या है? It is the bulk mass density of the soil when the soil is in fully saturated condition. So because in that case you have to take the total mass of water also. This is the, and in this case when the soil is fully saturated, you can also take the total volume, means volume of water plus plus volume of solids. Now in case of submerged, in case of submerged, in case of submerged density, it is the mass density of the soil when it is in submerged condition. As we know that volume of volume V of a soil in submerged condition displaces an equal volume of water due to Archimedes principle. Thus, the net mass of soil in submerged condition is reduced. So this is the formula. So these are the effects that how buoyant force will comes into existence. This is soil mass submerged under water. So this is the water, and this is the soil mass sample which you have taken, which is submerged under water. So a relationship between submerged density and saturated mass density can be found as under that total soil mass which is equal to mass saturated in this case. Therefore, soil is in submerged condition and there are no air voids. Acts vertically downwards. The buoyant force कितनी लगती है? This one. ठीक है? So considering the equilibrium of forces acting in the soil, net mass acting downward can be calculated as this. So this is the formula. So this is the relation. So at the end we can get this. Just right. So mass density of solids, it is equal to ratio of mass of solids to the total volume of solids. So in this case, you have only take the mass of solids and the volume of solids only. Now, in case of volume weight relationship, as I already told you that mass is to be replaced by weight. These relationships are in terms of unit weight. The only difference in bulk mass density and unit weight is that mass and weight respectively. Unit weight is also known as specific weight. This is the main point. You can know unit weight is also known as the specific weight. Bulk mass density, dry unit weight, saturated unit weight, submerged unit weight, and unit weight of solids. You have what the unit of bulk unit weight, bulk dry unit weight, saturated unit weight, submerged unit weight, and unit weight of solids. In case of in case of mass density, you have taken the sign rho, but in this case, you have to take the sign gamma. So in this case, there is a total weight. You have to take the total weight and total volume. So the difference between the mass, mass, mass unit and weight unit is all this. In when you have to taken the mass, you have take the value gram, kilogram, but in this case you have to take the value Newton per cubic meter and kilonewton per cubic meter. Rest is the same, that W is replaced by that M is replaced by W in case of weight volume relationships.